Hi everybody, we are going to do review sheet 5154 today. You did this for homework. If you have a question, you can just watch the ones you have a question about. So here we go, the first one. This is an algebra type problem. No trigonometry here. We're just going to get a common denominator. So this one gets times by y, this one gets times by x. Now we have a common denominator, xy. And our numerator is yc minus dx. Please do not cancel anything out of here. Nothing cancels because nothing factors. Remember, you must factor before you cancel. Okay, that was easy enough. Okay, now we got a complex fraction. And with a complex fraction, we've talked about this several times. One way, I think the easiest way to solve this is to multiply each piece by the common denominator. Now the common denominator of all the pieces, 1, 2, 3, 4, is xy. So we're going to multiply xy here, xy here, xy here, and xy here. On top, that gives me x squared y plus y squared x. On the bottom, this is why we did this. The x's are going to cancel, leaving me with y. The y's are going to cancel, leaving me with x. Now, it looks kind of promising in terms of canceling because I think I can factor. So let's see. What can we factor out of the top? Well, we can pull out an xy, it looks like. So if I pull out an xy, that would leave me with x plus y over, ooh boy, looky here, cancel, cancel, we are left with xy as our answer. That is not the only way to do that problem, but that is a straightforward and easy way to do it. Now we've got some trig. This is a simplify. I want you to look at this right here. You should recognize that's a cofunction identity. That's just cosine x times secant, which is 1 over cosine. Now what's going to happen when you multiply 1 over cosine times cosine? You're going to get 1. Whew, if they were all that easy, huh? Let's look at this one. This one looks familiar to me. I think we may have seen this one before. Your little heart should be pumping right out of your chest when you see this right here. Sine squared plus cosine squared is 1, so we have 1 plus tan squared over secant. Now, when you wrote 1 plus tangent squared, you should be leaping for joy because 1 plus tan squared is secant squared. So we have secant squared over secant, which reduces to secant. So that right there simplifies down to just secant. And finally, we have the last simplification in that section, 1 over sine squared plus secant squared over tangent squared. Now, I don't know about you, that's a mess. 1 over sine squared, now let's leave that one alone for a minute. Let's simplify this. Now, that is a, this is a case where we want to change into sines and cosines. So secant squared is 1 over cosine squared, and tangent squared is sine squared over cosine squared. Now you got a big fraction made out of 2 little fractions. You can invert and multiply, or you can do what we did over there and just multiply by cosine squared. That saves me from writing very much, but it's up to you. Either way, this is going to reduce to 1 over sine squared plus 1 over sine squared. That's 2 over sine squared, or if you prefer, and this is your option, 2 cosecant squared. You are perfectly fine leaving it as 2 over sine squared if you want to. Okay, now we're switching gears, and we're going to solve a couple of equations here in radians. This is no calculator. So the first equation we have is this one. Now remember, you are not proving this. This is not an identity. You are actually solving this. Your goal is at the end to come up with x equals some, like pi over 3 or something like that. We want to end up with some degree measure as an answer. So I'm looking at that equation, and it occurs to me that I can factor out a sine x, leaving me with 2 cosine minus 1. Sine x equals 0, or 2 cosine minus 1 equals 0. Now remember, sine equals 0 is a special angle. It is on one of the axes. Where does the sine, or y, equal 0? Right here and right here. So the answers to the first part of the problem are 0 and pi. Where does the cosine equal 1/2? Well, I'm going to need triangles for this one. And I'm going to draw triangles where the cosine is a positive number. Now cosine, remember, is x. So it would be positive in quadrant 1 or quadrant 4. Now I want the cosine to be 1/2. That means this side has to be √3 and the angle has to be 60. Oops, I'm in radians. So instead of 60, I'll write pi over 3. Because 60 is 1/3 of 180. So here's one of my answers, and that angle is pi over 3. Here is my other answer. It's all the way around to here. So that would be 2 pi minus pi over 3, which would be 5 pi over 3. 2 minus 1/3 is 1 2/3 or 5/3 pi. And we're done. The next one's actually a little easier. It says tan squared equals 1, which means tangent equals plus or minus 1 if I square root both sides. Now be careful. I know we're kind of tuned into 1s and 0s being special. They're special when you're dealing with sine and cosine. Tangent is 1 in a triangle. And I think you know that because you know you have a triangle where opposite and adjacent match. So certainly this triangle right here has a tangent of 1. So does this one, because here both sides are -1. Now that's where we're +1. Where is the tangent negative? Well, here and here is where the tangent is negative. So we are plus or minus in all 4 quadrants. How big is the angle? Well, you know it's 45. But in radians, that's 1/4 of a pi. So you have 1/4 pi in every quadrant. So your first angle is pi over 4. Your second angle is pi minus pi over 4, which is 3/4 pi. The next one is pi plus pi over 4, or 5/4 pi. And the last one is 2 pi minus pi over 4, or 7 pi over 4. Remember, this is pi. So this angle is pi minus pi over 4. This one is pi plus pi over 4. This is 2 pi, so this angle is 2 pi minus pi over 4. So here are the 4 answers to the problem. One more equation. Oops, I guess not. I guess we have some more equations after that, but one more without our calculator. Sine squared minus 2 sine minus 3 equals 0. Hopefully when you looked at this one, you saw that it factored. This is a quadratic equation, and it factors very easily into sine minus 3 sine plus 1. If you don't believe me, FOIL it out. That's what you should always do, FOIL to check. Now I'm going to set each one of those equal to 0 and solve, so sine is 3 or sine is negative 1. This is impossible. Sines and cosines cannot be bigger than 1. Think about it for a second. Sine is y over r, opposite over hypotenuse. Can opposite ever be 3 and hypotenuse be 1? Would that be possible? Absolutely not. Negative 1 is one of those special angles. The sine is negative 1 right here. This is where the sine, or y, is negative 1. So that's 3 pi over 2. So this problem ended up having just one answer, and it was 3 pi over 2. Now we're going to do exactly the same thing in part 3, except we're using our calculators. That simply means we're not going to do anything any different. It's just that the angles involved aren't special. So we're going to need a calculator to find the angles. So here's what I mean. Cosine x equals 0.37 over 2. How do we find an angle on our calculator? We use the second cosine button. Now, I want you to be careful of something, though. We are still solving, oh, I guess I better pay attention. We are still solving in the entire window of opportunity, around the entire circle. Now, we are doing it in degrees, so we'll want to make sure our calculator is set in degrees. But we're going all the way around. Your calculator is not going to give you all the answers. You have to stop a minute and think. We are going all the way around this circle, and we want a cosine that's positive. Cosine is x. So we're going to have an answer here, and we're going to have an answer here. Because x is positive in quadrants 1 and 4. So I'm going to make sure I'm set in degrees, and then I'm going to second cosine 0.37 divided by 2. And I get about 79.3 degrees. So in the first quadrant, the answer is 79.3. In the fourth quadrant, the answer would be 360 minus 79.3, which is 280.6, or 0.7. So there are the two answers to the problem. Again, exactly like what you've been doing, except we had to use a calculator. Take a look at the next one. We can factor out a tangent. And we're left with tangent plus 4. That means the tangent is 0, and the tangent is negative 4. Now, I'm not going to use a calculator for this one because it's just as easy for me to think about my circle, because I have to get all the answers. My calculator is not giving me all the answers. It's easier for me just to look at the circle. Zeros are special. Where does the tangent equal 0? Tangent is y over x. Y over x, right here. So x equals 0. Not here, that's undefined. Here, 180. Those are the two places where the tangent is 0. Now, where is the tangent a negative 4? Well, it would have to be in quadrant 2, negative, positive, or in quadrant 4, positive, negative. What is that angle? No idea. Second tangent 4. That angle is about 76, if I round it off. That angle is about 76 degrees. The answer is not 76. The answer is 180 minus 76, or 104, and 360 minus 76, or 2 84? Better check that. Yeah. And there are the answers to the question. One more in that section. Now, I don't like it cosecant squared, don't like that because I know I'm going to use my calculator and that's not on it. So if the cosecant squared is 5, the sine squared would be 1/5. I think I'll do it this way. Which means the sine is plus or minus the square root of 1/5. Don't worry about simplifying that. That's not the answer. The angles are the answers. Where are the angles located? Well, the sine has to be positive or negative. That's everywhere, gang. That's everywhere. That's the whole butterfly. How do I find the angle whose sine is the square root of 1/5? I type that into my calculator. Second sine, square root 1/5. And it's about 26.6. So I have this angle in quadrant 1, which is 26.6. I have this angle in quadrant 2, which is 180 minus 26.6, which is 153.4. Then I have this angle, which is 180 plus 26.6, or 206.6. And then this answer, the last one, which is 360 minus 26.6, or 333.4. So here are the 4 answers to that problem. Now we're going to verify. So here we go. Remember, I'm only going to do this problem one way, but there are really about a zillion bazillion ways to do it. So you choose the way that makes the most sense to you. Now, for me, doing this problem, I am going to get a common denominator and add these guys together. That's what I'm going to do. So I'm going to multiply this one by secant plus 1, and this one by secant minus 1. So on the top, I have secant plus secant minus 1. And on the bottom, I have secant plus 1 times secant minus 1, which I am going to now simplify. So on the top, I have 2 secant, which is awesome. And on the bottom, I have secant squared minus 1. Now, groupies. One plus tangent squared is secant squared. You should have that memorized. So secant squared minus 1 is the same as tangent squared. This is the same as 2 secant times 1 over tangent squared. Do not be confused by that. If you multiplied 2 secant times 1 over tangent squared, that's what you'd get. But 1 over tangent squared is cotangent squared. And you did it. B, I think we might have done at some point for a homework problem. So So what I want to do with this one, and again, there are infinitely many possibilities. Well, maybe not infinitely many, but there's a lot of possibilities. Let's change this into sine over cosine, and this into cosine over sine. Now I need a common denominator because I want to add those two fractions. My common denominator is going to be cosine sine. So this one needs a sine, and this one needs a cosine. So now what's my numerator? Woo, we're all excited. We got a sine squared plus a cosine squared up there. That's 1. So now I'm going to split that fraction sort of like I did that problem over there. I'm going to think of this as 1 over cosine times 1 over sine. Do not be confused. That equals that. 1 over cosine is secant, 1 over sine is cosecant, and you have done it. Next, we got to prove this. Oh, this is an easy one. Look at that. You don't even need me to do this one, I bet. 1 minus sine squared. 1 minus sine squared is cosine squared. So we have cosine squared times cosine, which is cosine cubed. Took longer to write it down than it did to do it. Easy, easy, easy. Okay, now we're going to find the sine of 15. You got many, many options. Again, I'm only going to do this problem once, so I'm going to do 60 minus 45. You have a ton of options. 60 minus 45 is 15. Formula says sine 60, cosine 45, minus cosine 60, sine 45. The sine and cosine of 45 are root 2 over 2. We have talked about that a lot. 60, I'm going to draw. Across from the 60 is root 3. So the sine of 60 is root 3 over 2, and the cosine of 60 is 1/2. Root 6 minus root 2 over 4 is our answer. Now we're going to do the same thing, only we're doing it with tangent. So the tangent of 75, this is going to be a little more arithmetic. The tangent of 75 is the tangent of 45 plus 30. Other ways to write 75, but that's an easy way. Now, tangent formula says tan of the first plus tan of the second over 1 minus tan of the first, tan of the second. Here's 45, and here is 30. So the tangent of 45 is 1, and the tangent of 30 is 1 over root 3, or root 3 over 3. So plugging that into my formula, I have 1 plus root 3 over 3 over 1 minus root 3 over 3. Kids, you cannot cancel. Please don't. Instead, let's multiply everything by 3. That will clear these fractions out, and we'll have 3 plus root 3 over 3 minus root 3. Now I need to rationalize that. It's kind of a mess, so let's multiply the top and bottom by the conjugate. 3 plus root 3. Foiling And I'm going to FOIL this kind of fast. You take your time, get a FOIL. 3 plus, oh not 3, I better slow down. 9 plus 6 root 3 plus 3 over 9 minus 3 when I FOIL. So I get 12 plus 6 root 3 over 6. I can cancel a 6 out, and your final answer is 2 plus root 3. All right, I'm going to find the cosine of 2x. And luckily for me, there's a formula that says 2 cosine squared minus 1. Life does not get any better than this, folks, because they told me the cosine. So 2 times 4/5 squared minus 1 is going to be the answer. The formula for cosine 2x is 2 cosine squared minus 1, or one of the formulas is 2 cosine squared minus 1. They gave me the cosine. I just plug it in. So I have 2 times 16/25 minus 1. That's 32/25 minus 1. The answer is 7/25. We're doing great. Not too much more to go. We want to verify that this equals this. Now, this is an easy one. You can do this because the formula says cosine of the first times cosine of the second, changing pi over 2 to 90, minus sine of the first, sine of the second. Here's 90. The cosine of 90 is 0. It's x. The sine of 90 is 1. It's y. So we end up with negative sine x, which is exactly what we wanted to end up with. Now, I've made a little note here. We talked about this in class. I'm going to go ahead and change that to a 270. 3 pi over 2 is 270. We talked about this in class, that we're not going to be able to use our tangent formula because the tangent of 270 is undefined. There's an asymptote at 3 pi over 2. So we're going to have to split this one up into the sine over the cosine. Now, I know that looks like a lot of work, it looks like a lot more writing, but these are easy formulas. You got these down. Plus, 270 is right here. So when I start plugging numbers in, I'm going to have some pretty easy numbers to plug in. Zeros and negative ones. It's going to be pretty easy. So here we go, on top. Sine first, cosine second, minus cosine first, sine second. On the bottom, cosine first, cosine second, plus sine first, sine second. Here we go. Every time we see a cosine 270, we're going to plug in 0. So I'm going to put a 0 right here. That's 0. So I have sine times 0 minus cosine times negative 1. The sine is negative 1. It is y. Over cosine times 0 plus sine times negative 1. These are gone, because when you multiply by 0, you just get 0. So on the top, I have a positive cosine, and on the bottom, I have a negative sine, which reduces to a negative cotangent. Awesome. And then C, which I believe we actually did together already, but let's do it again. Looks much more complicated than it is. We are going to use our sine formulas. So this one will be sine first, cosine second, plus cosine first, sine second. That's this right here. All that is that. Now plus sine first, cosine second, minus sine second, cosine first. So they're kind of backwards than I usually do. That's the second part. These two are going to cancel. These two are the same and they add together and give us 2 sine cosine. Voila. Number 7, these are the ones you guys are really good at. Hopefully you're good without the purple sheet. Letter A, we got sine cosine minus cosine sine. That's a sine formula. And since there's a minus in there, it's a minus. So it's 17 minus 13, so that's the sine of 4. So that's a formula for the sine of 4. Cosine squared minus sine squared. That's a formula for the cosine of 2x, twice an angle. Remember, cosine 2x is cosine squared minus sine squared. So you have cosine squared 19 minus sine squared 19. That's a formula for the cosine of 2 times 19, or 38. Think of this formula, only there's 19s instead of x's. So it's the cosine of 2 times 19. 1 minus cosine over 2, the square root of 1 minus cosine over 2, that's your half angle identity for the sine. The difference is, instead of x's, this time you have a 12 here, so you got a 12 here, and that's the formula for the sine of 6. 12 divided by 2. 2 sine cosine is your formula for sine 2x. The difference is we don't have x's, we have 83s. So this is a formula for the sine of 2 times 83, or 166. That is D, 7D. Your tangent formula says tan x plus y equals tan x plus tan y, or 1 minus tan x tan y. The difference is, in this example, E, you got a 12 and a 5. So this is a formula for the tangent of 12 plus 5, or 17. F, I have identified for you as tricky. We did one of these in class a couple days ago. This is backwards. This is not a formula the way it's written. It's backwards. So I'm going to take a -1 out and turn it around. Now it is a formula. What is it a formula for? It's a formula for the cosine of the angle plus the angle. So this is the formula for negative cosine 26. Remember the formula for cosine. When you have an addition, that would be cosine 15, cosine 11 minus sine 15, sine 11. That's what we have. So that's a plus 26. And finally, we are almost done. We have one more solve. This solve, we're told to do it in degrees. I would imagine the directions should be written this way. So here we go. Now, we talked about this when we did our double angle work. We talked about the fact that you can't do this problem with a 2x in it and a regular x. You can't do that. So we're going to get rid of that 2x, and we're going to replace it with one of the formulas. Cosine 2x is the one that you have 3 formulas for. You need to choose the best option. So the best option in this case would be 2 cosine squared minus 1. Now some of you are asking yourselves, why is 2 cosine squared minus 1 the best option? Because there's another cosine in the problem. So let's keep it all cosines, since we have that option. Now, that's a quadratic equation. I'm going to go ahead and put it in descending order. I like that order better because I know my next step is going to be to factor. So since that's a 2 cosine squared, I'll need a 2 cosine times a cosine. That's a 1. Now I'm thinking of the foiling process, and I want that to end up positive there. So I think I got to put my plus here and my minus here, so that when I FOIL this, I get a positive 2 cosine and a negative 1 cosine. That will give me what I want. So cosine equals 1/2. That comes out of this parentheses. 2 cosine minus 1 equals 0. Or cosine equals negative 1. I'm going to do this one first because it's the easiest. Remember, cosines and sines that are 0 and 1, or negative 1, are special. So I just need to look around the circle, and where does the cosine, or the x, equal negative 1? Right here. So one answer is 180 degrees. That's where the cosine is negative 1. Now where is the cosine 1/2? Well, I don't know, but it's a positive number, so it's got to be in quadrants 1 and 4, because x is cosine and x is positive in 1 and 4. The cosine is 1/2, that makes this a √3, which means this angle is a 60 and so is this one. So what are the answers to the question? There's your first angle, it's 60. Here's your second angle, it's 360 minus 60, or 300. So there are the 3 answers to this problem, and that worksheet is complete. Yay! Good job.